Physical changes are changes in physical properties that occur without changing the identity of the substance. The substance remains the same. Examples include changes of state, such as melting, freezing, boiling, any kind of change of state. You can also have changes in shape. That would include cutting, tearing, denting, stretching something. If you change its shape, you haven't changed what the material is. Whenever you dissolve something, dissolving is always, which is a very common thing for us, but dissolving is a physical change, because when you dissolve a solute, such as making salt water, the salt is still present. If you were to taste it, you would be able to taste the salt. If you evaporate the water away, the salt, which is a physical change, the salt is going to remain behind. Chemical properties, on the other hand, are properties that you can only see when you change one substance into another substance. So chemical properties describe how a substance is going to interact with other substances. As an example, hydrogen in the presence of oxygen gas with a spark burns to produce water vapor. Hydrogen is different from oxygen, which is different from water. So substance 1, substance 2, substance 3. These two, hydrogen and oxygen, have united to form water vapor, which is H2O, a compound. Sodium metal will burn in oxygen to produce sodium oxide. We have a metal, unique properties, unique physical properties. Oxygen gas, its own unique physical properties, but when you put them together and provide an energy source, then they're going to produce a new compound, which is a solid white crystalline compound, sodium oxide. So as some examples, more detail with this. Sodium is a solid at room temperature. It's soft. It can actually be cut with a knife. The cut surfaces tend to be shiny when you cut them. They have luster, which is typical of a metal, because sodium is a metal. Its melting point is 98 degrees Celsius, fairly low for a metal. Its density is 0.971 grams per cubic centimeter. So for instance, it will float on water because the density is less than water. Whenever you place water, those were physical properties. The chemical properties would include whenever you place sodium with water, it reacts violently to produce sodium hydroxide and hydrogen gas. So you get bubbles, you get heat, you get flame. It burns in oxygen to produce sodium oxide, burns brightly in oxygen, and it also burns or reacts with chlorine gas to produce sodium chloride, or plain old table salt. You'll notice that in all of the chemical properties, we have sodium reacting with something else, with water, with oxygen, with chlorine gas, to produce some other substance. That is a good indicator that you have a chemical property if you have one substance interacting with a second substance. One of the physical properties of chlorine, you have gas at room temperature. It tends to be a yellowish green color. Low boiling point, negative 34 degrees Celsius. Its melting point is negative 150 Celsius. Chemically speaking, it reacts strongly with most metals, reacts explosively with hydrogen to produce hydrogen chloride, which is the same thing as hydrochloric acid once it's dissolved in water. It's very toxic to living things. Very few living things can live in the presence of chlorine gas. Because of that, it's been used as a chemical weapon. When you put these two substances together, very strong reacting substances, the substances that are formed are very different from the materials that were there before the change. So for instance, if you put sodium, Na, plus chlorine, which is Cl2, you're going to produce sodium metal chlorine gas. You're going to produce salt, NaCl. Properties of sodium chloride physically. Salt is a white crystalline compound with a high boiling point, 801 degrees Celsius, a high melting point, 1,465 degrees Celsius. Chemically, it's very stable. It reacts with soluble silver compounds to form insoluble silver chloride, and it is consumable by people with no toxic effects except in very large amounts. Whenever we have, as an example, sodium plus chlorine yields sodium chloride, we have sodium and chlorine here, and we have sodium and chlorine here. The chemical change does not create new matter. The law of conservation of mass says that for every atom of an element during a chemical change, we have to be able to locate it before and after the change. So as an example, we have 2 sodium atoms here. We have 2 sodium atoms in the end result. We have 2 chlorine atoms, and we have 2 chlorine atoms. What's happened, though, is that the chlorine atoms have separated from one another and have united with sodium atoms. So we didn't lose anything, which is the law of conservation of mass. Matter can neither be created nor destroyed in a chemical reaction, but it does change form. So even though we have all the atoms are present, they are rearranged and chemically bonded on this side in a way that they were not bonded on this side. That is the chemical change. So as we summarize properties of matter, so summarizing the properties of matter, we can separate them by asking the question, are the properties that we're looking at determined without changing the identity of the substance? If the answer to the question is yes, then we have physical properties. Physical properties can be either intensive or extensive properties. Intensive do not depend on how much we have. Here are some examples of intensive properties. Extensive properties do depend on the amount, and here are some examples of extensive. If we answer no to our original question, are properties determined without changing the identity of the substance? If we answer no, then we have chemical properties. And chemical properties, we want to know how does the substance react in the presence of other substances, such as air, an acid, water, bases, other chemicals, and also what happens if it's heated. Does it break apart? Does it combine with oxygen? Those would be chemical properties. In summary, physical change is a change in a physical property, does not change the identity of the substance. Chemical changes are changes which alter the identity of the substance, and new substances are produced.